I am going to shrink. Oh my God, what's happening? Okay, here I am. That's probably the right size for me, yeah? Maybe I should be a little bigger.
Let's talk science.
Talk about science.
Good afternoon and welcome to NASA's Goddard Space Flight Center. We are live today with
Does it
NASA
sound good, or
experts who
should
are
I bump it
excited
up?
to share the latest images we have of the interstellar comet 3I Atlas.
There we go. How about
3I
that?
means third interstellar, and Atlas refers to the NASA-funded Atlas Survey telescope, which made the discovery. We are joined today by Amit Shathria, NASA's Associate Administrator, Nikki Fox, Associate Administrator for NASA's Science Mission Directorate, Sean Domagal-Goldman, Director for the Astrophysics Division, and Tom Statler, Lead Scientist for Solar System Small
All right, three
Bodies
guys and
in the
one
Planetary
woman.
Science Division. We'll be taking questions from the media on the phone bridge and through social media, but before we get started, let's learn more about this fascinating comet and share some images.
How about that?
Amit, kick us off.
Hi, everyone. America leads the way in space exploration. As Courtney noted, a NASA-funded telescope, the Atlas Survey Telescope in Chile, first reported observations of the comet on July 1st, 2025, to the Minor Planet Center. And NASA has been tracking and studying Comet 3I Atlas ever since. We're here today to give you the latest of what we know about Comet 3I Atlas and what we still want to know. But first, what is a comet? It's a small, natural, solid body that is a combination of rocky and icy material that evaporates as it warms when it's close to a star, like the sun. But to start with, I'd like to address the rumors right at the beginning. I think it's important that we talk about that. This object is a
I'm turning
comet.
it up.
It looks and behaves like a comet and all evidence points to it being a comet. But this one came from outside the solar system, which makes it fascinating, exciting, and scientifically very important. This is only the third interstellar object like this that humanity has ever found. And a little bit more
Yeah,
about the
that?
rumors. I think it's very important, and I'm actually very excited that a lot of the world was speculating about the comet while NASA was in a period where we couldn't speak about it due to the recent government shutdown.
Okay.
I think what I took away from that whole experience and watching that as we were working during the shutdown was just how interested and how excited people were about the possibility of what this comet could be. There was a lot of speculation about what it could be, but what I think is really awesome is that folks were interested in this incredible finding that we observed and that that came from the heavens, and what that means, what it could mean about how magical the universe could be. It expanded people's brains to think about how magical the universe could be. And I'll tell you, here at NASA, we think that every day. And so it's really great that you were able to join us while we were not able to comment because of the shutdown constraints about what that comet is, because we think the universe is a magical place, and we spend your treasure and we spend all of our time trying to make sure that we explore that and share with you as much as we can. In fact, we want very much to find signs of life in the universe. In fact, just a few months ago, we were with you and we talked about what we think might be the signal from ancient life on the surface of Mars from our amazing machines that have been roving the planet for 30 years to look for those things. That is something that's really important for us to learn about and discover. It could be an amazing discovery if and when we can confirm that. But 3I Atlas is a comet. So my colleagues from the Science Mission Directorate will go through the images in detail. But just to give you a peek, here's one of the images from the closest physical instrument we had to the comet, from the HiRISE instrument on our Mars Reconnaissance Orbiter, taken on October 2nd as the comet sailed by at a distance of 19 million miles from the instrument. You can see that Comet 3I Atlas looks like a fuzzy white ball. That ball is a cloud of dust and ice called the coma, which is shed by the comet as it continues its trajectory towards the sun. I'll leave it to my esteemed colleagues to share further details, and I'd like to introduce you to the head of NASA Science, Nikki Fox.
Thank you so much.
It is such a rare opportunity
for us to be able to observe this interstellar comet. And NASA Science has been given this really, really exciting opportunity to do it, and literally from the moment of its discovery. Just like Amit said, comets are tiny cosmic snowballs, and by studying them, we can learn about the environment from, basically where they formed, where they came from. This one came from a different environment from our own, and so we're already starting to see some really interesting differences to comets from our own solar system. 3I Atlas, as you heard, is the third known interstellar object to pass through our solar system, the first one being identified in 2017. while these types of interstellar objects have long been predicted, we are just beginning to be able to find them thanks to the newest technologies with our network of Earth-based telescopes, which are designed to find small, fast-moving objects in space. The NASA-funded Atlas Survey Telescope, which made the discovery, is part of NASA's Planetary Defense Network. Our telescopes are always watching the skies to keep us safe, and in doing so, they occasionally make major scientifically interesting discoveries, just like this one.
It's true, we wouldn't see it
Right
without
away,
them.
of course, NASA's Planetary Defense Coordination Office they studied it, and they established that 3I Atlas is not a danger to Earth. In fact, it's at least twice as far away as the distance between the Earth and our Sun. On October 30th, the comet itself reached the closest it will ever be to the Sun when it crossed just inside Mars's orbit, which is why the image that Amit just showed, he noted it was the closest instrument physically to the comet, because the comet was right inside the orbit of Mars. Earth was on the opposite side of the Sun, which is about as far away as our planet can possibly be from Mars. It's been clear from the moment of discovery that the comet was going to pass on the opposite side of the Sun from where the Earth is. However, it was also clear that its positioning behind the Sun was going to make observations from Earth very, very difficult. And that is why we are so happy to have our incredible fleet of NASA science spacecraft all across the solar system.
Like
and boy,
Mon
were they
Mothma.
ready for this
She's
event.
got like the Mon Mothma
NASA's
vibe going
science
on. The
assets
hair, the
on
white,
board our
everything.
missions have provided the United States the unique capability to observe 3I Atlas almost the entire time it passes through our celestial neighborhood. Everything NASA science does is interconnected, and nearly 20 mission teams have been working together to really rise to this challenge. 20 mission teams, by the way, and counting. Everything we're learning about the comet is possible because of the distribution of all of the different instruments on our spacecraft with different capabilities. And I'll note that for some of them, we've even pushed our scientific instruments beyond their normal capabilities, beyond the things that they were designed to achieve, to allow us to capture this amazing glimpse at this interstellar traveler. In other words, we can study this comet so
Can you guys hear
well
me, by the way?
because
You
we
should be
have
able to hear me
many
now.
different
Let me know.
assets in different locations, observing things in different wavelengths, in different ways, with different instruments, each set of observations providing a different lens for understanding objects in the sky.
Okay, so yeah,
So
since she
NASA's
looks like
science
Mon
team has kept
Mothma
watch on 3I
with the
Atlas
white,
for
the
nearly
hair,
its
everything.
entire journey through the
Star
solar
Wars.
system for the first time ever. So I'll just quickly go through the timeline of which NASA spacecraft have observed the comet thus far, and we're still going. There will be more opportunities to observe this comet as it continues its journey through the solar system, passing the orbit of Jupiter in spring of 2026. So the NASA assets that are gathering observations of 3I Atlas include Hubble, the James Webb Space Telescope, TESS, SWIFT, SphereX, Perseverance Mars Rover, Mars Reconnaissance Orbiter, MAVEN, Europa Clipper, Lucy, Psyche, personal favorite, Parker Solar Probe, Punch, Stereo, and ESA, NASA's SOHO mission. And I'll note that Parker Solar Probe's data were just downloaded yesterday, and indeed, we did catch several glimpses of this amazing comet. The scientific community is hard at work analyzing these images, and everyone, as always, is welcome to take a look. At NASA, we embrace open science. We make all of our data available to the public 24/7, and we invite, in fact, we really want you to tell us what you're observing and what you think about what we're looking at.
Here's
We're
their
still
image
learning
gallery.
even
They
about
haven't
what
updated
questions
with
we
any of the
still
new
need
stuff
to
yet,
ask.
but they
And
probably
this,
will
of course,
soon.
is the scientific process in action. All the data go to a public archive. We get those images as soon as we're able to from all of our eyes in space. As always, I am excited to see what new things we learn about our friendly solar system visitor in the days and, in fact, the years to come. So now I'm going to pass over to Sean. He's going to tell you about what our astrophysics missions have seen. They, of course, were some of the first things to look at the comet, and images from several of them have been available since the beginning of the summer. So I'm going to ask you to set the stage for us. Tell us what we've already seen before we hand over to Tom to tell us all the new stuff. Take it away, Sean.
Thanks, Nikki. Happy to. To give you some background, NASA's astrophysics missions, like all our missions, they are designed to do things that would otherwise be impossible. In this case, our nation's space telescopes stare deeper and more sharply into the universe than any other observatories in the world. And that means we're often the first to follow up and study near-Earth objects or comets like 3I Atlas after they're initially detected. That same powerful gaze that lets these telescopes see distant galaxies, those little red dots you might hear about, they also allow us to observe details about objects like 3I Atlas a little bit sooner. And the earlier we learn about these objects, the earlier we can share this information with the world, including the science community and our partners across the planet.
The NASA live stream does have a chat,
or
and
other
it's
space-based
hilarious.
assets, so that they can conduct,
It's just like
conduct
this one,
additional
everyone's saying
observations
liars.
with their telescopes.
Man,
In this
it's
case, our
funny.
astrophysics missions came together to take advantage of this rare opportunity to study this comet that came to us from outside the solar system. From our flagship space telescopes to
Nonstop
smaller
clown
missions like
emojis.
TESS and SWIFT, they all have, as Nikki said, different complementary capabilities. They don't just do things that would otherwise be impossible, they do things that even our other great telescopes can't do. So every time we add to the fleet, we add additional capabilities that expand the realm of the possible. In this case, it let us refine the orbit of this structure early on, determine what its structure is and what its composition is, what it is made of. It's a beautiful illustration of why we have not just one space telescope, but a fleet of them, because every one member of that fleet specializes in a different kind of information, contributing a different piece of the puzzle to the total understanding we have from the fleet as a whole. So for example, Old Reliable, NASA's Hubble Space Telescope, celebrated its 35th birthday earlier this year. And not too long after that, in July, it looked at 3I Atlas, not long after we discovered it from the ground. At this point, 3I Atlas was about 277 million miles from Earth. And what Hubble's images revealed was a few things. First, a teardrop-shaped coma of dust coming off that solid, icy nucleus of the comet itself. From these data, astronomers were able to more accurately narrow a few things. Importantly, the size of the nucleus. We now know it's between, at that point actually, we knew it was between 1,400 feet in diameter up to as large as 3.5 miles in diameter. And Hubble also saw that the comet was losing dust, and not just losing it, but losing it at a rate consistent with other previous sun-bound comets that originated from within our solar system, consistent with the physics that we figured out from watching those objects. Now, the last thing Hubble did is it gave us a better understanding of the orbit of this object. Tell us not just where it was, but where it was heading, so we could point other observatories at it, such as the James Webb Space Telescope. We added this to our fleet early in this decade. We didn't have it when the last two interstellar comets came around. And what James Webb did, and its companion SphereX, which we only launched at the beginning of this year, is it added infrared observations. The power of infrared observations is, these are colors we can't see. They're redder than what our eyes can detect. And infrared light is particularly good at helping us understand the composition of objects. We can see little molecular fingerprints from the things that the objects are made of. So with these infrared observations with James Webb and SphereX, we detected an abundance of carbon dioxide gas in the comet's coma and in the bright cloud of gas and dust surrounding that comet as it approaches the sun.
I just posted
those
this to
molecular
Twitter.
fingerprints I
NASA's
mentioned, those
best
are the
image
little,
of
like,
3I
science wiggles you
Atlas
might
from
see in
the
top
live
right of these
stream.
images. We now
It's just
know
a
from
blob.
seeing those science wiggles, those fingerprints of those molecules, that the comet has a nucleus rich in carbon dioxide as well as the presence of water ice. Now, the ratio, like, we can not just say that these things are there, we can also say, what's
There's a
the
lot of
ratio
people that
carbon
think that
dioxide to
they
water?
actually
And
down-res
we now
these
know that.
images
We know
because they're
it's
so
larger
blurry.
than what we usually
These
see
are
in
so
solar
blurry,
system
people think that they
objects.
took them and
But
down-res
there's
them
a lot
intentionally.
of natural explanations for that. For one, the carbon dioxide is going to kind of bake off that comet earlier on when it's far away. But there's other well-understood processes that could also explain it. I'll just, to put this in context, there are, every time we look beyond our solar system and we look at the ratios of carbon dioxide to water, we see, whether it's a star or a planet, different ratios than we see in the solar system, and that's true for this comet as well. So it could mean, and this is the last theory of why those ratios could be different, that these ices could have been exposed to higher levels of radiation than comets in our own system. Or, as I said before, it could be that the comet just formed from a region where carbon dioxide ice was particularly abundant and different from our solar system. Other missions like our SWIFT spacecraft, which studies X-rays and gamma rays, have also observed the comet. Teams even looked back through data from our TESS mission, which was designed to look at exoplanets, and found observations of the comet as early as May. That information is helping us understand the comet's history before it got closer and when those other observatories pointed at it once we knew where it was. Now that the comet is near, relatively speaking, our planetary and heliophysics missions have joined in to tell us more. And now I'm going to turn it over to my colleague Tom Statler to talk about some of those new images.
All right, thanks very much, Sean. Before we get started, I just want to remind everybody of where we are, who is where in this play. As you saw in the animations, while Nikki was speaking,
I want to say that none of these
the sun,
people
of course, is
bad
at the
people.
center of our
They all
solar
seem
system.
like
The planets
good
are
people.
orbiting around the sun.
But why are they doing a press
and in this
conference
case,
for
Comet
that?
3I Atlas has come through on a trajectory
for that.
in the opposite direction and has arrived at its closest point to the sun when the Earth was on the wrong side for us to conveniently observe. But Mars was on the correct side of the sun, and our Mars assets were able to observe the comet, and also several of our other spacecraft were on the correct side of the sun. So the scientific community is really excited about the comet and about these new observations. I'm tremendously excited to help share them with you today. This is a new scientific opportunity, and it's a new window into the makeups and histories of other solar systems. We're just beginning to learn about these types of objects and figure out what are the right questions we should ask about them. Now, let me start by going directly to what we were able to see at the beginning of September, when Psyche was able to see the mission. So before that, though, in August, we organized a workshop. We organized a coordination session for the missions across the NASA fleet that had good opportunities for potentially observing 3I Atlas, so that we could all share observing plans and knew what was going to be possible with our assets. I can't emphasize enough now how, thanks to the cooperation of so many mission teams, we will be accumulating a wealth of data on this comet that the science community will be digging into for years. Now, let's go back to September, and I can show you a sampling of the images collected by our different mission teams. To set the context, you're going to see a comet that's a small body with a coma around it, basically a fuzzy blob. Now remember, space is big. Nothing is ever really as close as you like, and all of these observations are very, very difficult. It's a little bit as if our NASA spacecraft were at a baseball game, watching the game from different places in the stadium. Everybody's got a camera, and they're trying to get a picture of the ball, and nobody has a perfect view, and everybody has a different camera. Now, let's return to September and see the first images from the Psyche spacecraft. NASA's Psyche mission acquired 4 broadband black and white images of the comet over the course of 8 hours on September 8th and 9th, 2025. The comet was about 33 million miles from the spacecraft at that time. And you can see in the image the large frame where the comet was seen at different times. Down in the bottom left is a blow-up, a stack in addition of all of those observations. The Psyche spacecraft is on its way to an asteroid in the main asteroid belt that's also named Psyche, and these images were the first captured from this perspective. Now, if you think in that lower left you're not seeing very much, just wait a minute, you'll see more. Now, the following week in September, the Lucy spacecraft observed the comet from the opposite direction. So let's take a look at the Lucy image. This is another broadband black and white image made by adding up a series of individual exposures that were taken on September 16th. Lucy is on its way to study asteroids that share Jupiter's orbit around the sun, called the Trojan asteroids. Lucy was 240 million miles away from 3I Atlas, which is circled in the center, when its high-resolution LORRI camera caught the comet. You can see the comet's coma, the fuzzy halo of gas and dust surrounding 3I Atlas, and its tail, a smudge extending to the right of the comet. If you were the Lucy spacecraft looking at the comet from this angle, the sun would be a little bit over your left shoulder, and so the comet tail is pointing away from the sun, as we've seen many times before in solar system comets. For scale, this image spans about 1/3 the width of the full moon as you'd see it on the sky. Of course, at the distance of the comet, that's a much, much larger region of space than the moon. Now, this looks a little different from the Psyche image. Part of that is because the cameras are different, and part is because of the ways the Psyche and the Lucy teams decided to show their images. But also, it's because we're seeing the comet from different directions. Seeing a comet's coma in different lighting geometries, with the sun coming from different directions, is one of the key ways to learn about the physical properties of the dust that's been launched off its surface. And I want to emphasize that you do not get these views unless you have spacecraft farther from the sun than the comet is, so that you can see it backlit. We could not get this view from the vantage point of the Earth. So combining the data from Lucy, Psyche, and Earth-based telescopes, scientists are hoping to better understand both the three-dimensional structure of the comet and the nature of the dust. It's a rare opportunity to compare ancient dust from a distant solar system to that from our own. Now let's go to the next picture from the MAVEN spacecraft at Mars. At the beginning of October, 3I Atlas passed within 20 million miles of Mars, which gave our Mars spacecraft an opportunity for a close-up. And earlier you saw the image that Ahmed shared from our Mars Reconnaissance Orbiter. MAVEN is another Mars orbiter that has been studying the Martian atmosphere since 2014. Now, this picture is not a direct picture of the comet itself. It's a spectrum. You're seeing the science wiggles that Sean was just talking about. This is some of those science wiggles where the instrument, the spectrograph, the ultraviolet spectrograph on MAVEN, has looked at the comet and also split up the ultraviolet light according to color. So you're seeing three different bands in this image. On the right, you're seeing emission from hydrogen gas in the atmosphere of Mars. In the middle, there's
NASA's here, they're knocking on the door!
Indicating it's coming from hydrogen gas in interplanetary space. And on the left, that blob is the signature of hydrogen gas coming from comet 3I Atlas. It's a little blob rather than a big streak because the comet is a small object in the sky relative to great big gigantic Mars and interstellar space that fills the entire field of the instrument. That definitely tells us, first of all, that the comet is there. If there were no comet, there would be no little blob on the left side of the image. But it's also telling us it's one of the many ways that we're able to discern the chemical composition of 3I Atlas. And in this particular example, it's showing us the hydrogen gas that's coming off of the nucleus. Now, MAVEN's observations, combined with the earlier observations by Swift and Webb that Sean spoke about, will help determine the water production rate, how much water vapor is released from the comet when the comet is warmed by the sun, which provides insight into the formation of the comet and its journey through our galaxy. Now, the European Space Agency and NASA's Solar and Heliospheric Observatory, or SOHO, also successfully imaged 3I Atlas from October 15th to 16th after it had passed Mars. And SOHO spotted the comet crossing its field of view from approximately 222 million miles away, or more than twice the distance of Earth from the Sun. Comet 3I Atlas was expected to be too faint for SOHO to see, but this result was made using detailed image processing and overlaying, or we call it stacking, subsequent telescope images. And this image highlights the value of spacecraft and instruments designed to look directly toward the sun, as Nikki was saying before, not only to study the sun, but also to have the ability to see other objects crossing in this case behind the sun from the telescope's point of view. You'll be able to see the rest of the images on our 3I Atlas website, go.nasa.gov/3I-Atlas. And there will be more to come. Not all of the data have been downlinked yet through NASA's Deep Space Network, and there are more observations still in work. And also, it's a long way from where we are today, seeing the initial images, to then making sure that they are accurately calibrated and processed to do science with, and then doing the analysis, combining the data sets, understanding them, and finally producing the scientific understanding, the knowledge of what this all means, which will be published in peer-reviewed scientific journals. The answers will come later on. We are still at this phase, very much in the state where we're figuring out what are even the right questions to ask about interstellar objects. This is a snapshot of where we are very early in the scientific process. Okay, back to you, Courtney.
All right, thank you all for your opening remarks. We'll go ahead and start the question and answer portion of this event. Just a reminder to our media on the phone bridge to press star
Q&A,
1 to
let's
enter
go.
the queue and ask your questions. We'll take our first question from the phone bridge from Marcia Dunn with the Associated Press.
Yes, hi. Based on your latest observation, what more can you tell us about the potential shape of the comet? Can you fine-tune any more on how big or small it might be, origin, all that sort of thing? Thank you.
Thanks for that question. There's a lot of territory to cover there, so let's see what I can do. The size of the nucleus still has yet to be pinned down. The best data are still from the Hubble observations that Sean was talking about. So we're still right now in that range of somewhere in the vicinity of a couple of thousand feet to a couple of miles diameter, but we'll get better on that one. The shape of the nucleus is also difficult to pin down because generally we're not resolving it in our observations. It's obscured by the dust, and especially it's obscured by the reflected sunlight off of the dust in the inner part of the coma. But what observers from the ground have been able to do is observe the brightness of the center of the comet over time to see if there's a modulation of that brightness that would be an indication of rotation. And it's very difficult to discern. So what it's looking like so far is that there's not a big, the shape of the nucleus is not very far from being round. It's not, doesn't seem to be a big, or at least we're not seeing signatures of a very elongated object yet. There's a lot still to come there. I think you were also talking about origin. It would be great, it would be fabulous if we could trace back the incoming trajectory into the solar system and trace that back and figure out where it came from. But things are not quite so simple. Our galaxy, as Sean knows, is a big and complicated place. And the sun and all the other stars in our galaxy are in orbit around the center of the galaxy. And so 3I Atlas has been in interstellar space for a very long time. There is circumstantial evidence, given how fast it has come in to our solar system, that it came from some very old population, some solar system around a very old star. Quite possibly, we can't say this for sure, but the likelihood is it came from a solar system older than our own solar system itself, which gives me goosebumps to think about, frankly, because that means the 3I Atlas is not just a window into another solar system, it's a window into the deep past, and so deep in the past that it predates even the formation of our Earth.
This is showing
and
the
our sun.
sunward-facing tail. This is October 3rd data, or October
All right, we'll take our next question
2nd,
from the
or
phone bridge
October
from
2nd
Bill Harwood with
the
CBS.
Mars Reconnaissance Orbiter. It's just not showing a anti-sunward tail, it's showing a sunward-facing tail. That's the best image that we got from NASA.
We can't hear you.
Try me again. This is Bill Harwood again. Can you hear me?
We have you loud and clear.
Okay, thanks. Sorry about that. Amit mentioned the rumors that were, kind of scurrying around about this thing in the weeks leading up to this briefing today. I have two questions for anybody who would care to answer. One is, did any of you seriously, did you take seriously the proposition from some that this could be an alien spacecraft? I doubt you did, but I'm asking the question anyway. And number two, is there any evidence you see in any of the data you have that would fit an explanation like that? Or as far as you're concerned, does all of this data say conclusively that this is simply a comet that happens to be passing through the solar system? Thanks.
So I'll take that one, Bill, and thanks for the question.
Mon
We
Mothma is
love
up for the
all
challenge.
of the different science and all of the different kind of hypotheses into what these things can be. When you start seeing something, you just got to point it's natural to wonder what it is. And we actually love, as Amit said, we love that the world wondered along with us. And that's such a cool thing. We certainly were able, because of the measurements that Sean described from the astrophysics telescopes that immediately turned on this object once we'd found it. And even, I was interested, I just learned that we'd actually gone back and actually seen it before we even found it. So that was super cool. I just heard that from Sean. But, we were very quickly able to look for sort of, the easiest thing to do, I'll put it in a different way, is if you understand comets pretty well and you understand asteroids pretty well, you kind of know the signatures that you're looking for, and so you can sort of look for those quickly and tick them off and say, yep, it really does behave like a comet. The interesting thing that, Tom, I know if I throw this to him in a second, he's going to geek out about it. But the really cool thing about this is the differences, because it comes from somewhere else. And that's why we're so excited about it. It's only the third time that we've been able to identify and track
Take a shot
something
for every
coming
ring
from
that she's
outside our own
wearing.
solar system. We've long
Let me get the
predicted
alcohol.
these things occur, and now, of course, we know better how to look for them, and we now have this amazing Atlas array. We're expecting we'll find a lot more of them, but it was quick. We were quick to be able to say, yep, it definitely behaves like a comet. We certainly haven't seen any techno-signatures or anything from it that would lead us to believe it was anything other than a comet. But the super cool thing is not that it's exactly like all the comets that we see in our solar system. It's the differences that are so tantalizing for us as it gives me goosebumps too. It could be from something that existed before our own solar system. That is so cool. It's from something that predates even our own star. Yep, it's going to look different because it didn't come from our solar system, and that's what makes it so magical. You want to geek out a little bit, Tom?
You were geeking out so expertly, Nikki, to begin with.
Embracing
that was fabulous. But that's exactly right. I mean, things from other places, we naturally expect them to be different from our own homegrown variety. And I like to imagine if you're fortunate enough to have grown up in Hawaii and you only drank Kona coffee, you love your Kona coffee, and then somebody says to you, well, gee, have you tried Sumatran? You're going to say,
Kona
well,
coffee
do you expect it to be different? And they'll say, why don't you try this? And you try it and you say, wow, that's really different. And you realize, well, I expected this to be different because it was from someplace else. It was a different environment in Sumatra. Now, does that one sip of coffee tell you everything about the weather in Sumatra and the soil and the people who harvest the coffee? Bless them. Of course not, but it's different, and yet it's still coffee. And that's what we have in this case. We have a cometary body. It behaves, it resembles the homegrown comets that we have in our solar system, and yet it's excitingly different in particular ways. It does the same thing comets do. It evaporates carbon dioxide gas.
I'm laughing because
it
of this
evaporates
live stream
water.
chat. You guys are hilarious.
But it's evaporating more
This is
carbon dioxide
nonstop.
compared to water. So that's a very interesting thing. Comets evaporate dust, and the dust is broken down. The minerals are broken down by the ultraviolet light of the sun. And comets, we know comets put out nickel, they put out iron. That's what comets do. This particular one is putting out more nickel than iron. That's really interesting, really remarkable, and something to be studied in the future. So we're always interested in new ideas. We're always interested in new suggestions, and all ideas are good when they're born. But those that stand the test of time, those that stand up to testing, those that are supported by the evidence, are the ones that survive.
Time to drink the coffee,
our next
guys.
question on the phone bridge.
This is actually an
And that one
advert
comes
for
from
Hawaiian
Matthew
coffee,
Glasser with ABC.
tariff-free.
Good afternoon. Thank you for doing this. Tom mentioned that the answers will come in time. I'm curious about what are some of the hopes that we might discover from this comet. What might it tell us about our planet, about our solar system, about the universe? Are there key things you're looking for as you start to analyze this data, and are you excited about anything in particular when it comes to better understanding how things are working out there?
Sure, I can take that. Every new object we discover is a new piece in the puzzle. What we're trying to do always is to understand the universe. That's part of the NASA mission, is to understand the solar system, understand the universe, understand the origin of planets, the origin of life. And that is a huge question, and we get little bits, little clues to parts of that puzzle. And
Yeah,
we
I'm
start
not
trying
going to
to
ask them a question because
together.
I would have to
gained
call them,
tremendous amount of
and they're
information
only taking it from
hundreds of
like,
years of astronomical
professional
observation
media outlets.
and from decades
They're going
of
to do a
in-situ
Q&A in their
spacecraft
live chat
observation has
later.
revealed our planets as actual places.
But that's going to be a madhouse, so I doubt they would see mine.
We've learned about comets and asteroids, and we're beginning to put together a picture of how all of those planet-forming minerals and planet-forming ices came together to form our planets, and how our solar system changed over time. Just one example, we get a fascinating clue from the objects like Pluto that we've been discovering since the 1990s, the trans-Neptunian objects, the way they are
Don't forget what they did to
through
Pluto,
space in
guys.
the outer solar system.
They demoted
show us
Pluto.
clues to how the orbits of the major planets may have changed over time in the early solar system. A fascinating thing, and questions that we would never have thought to ask before we knew about these trans-Neptunian objects. Now, interstellar objects, like I said before, are new windows, and it's windows that we've never even looked out of before. So what we're going to find is way too early to predict, but I think we're getting a hint of the breadth, the wide spectrum of conditions that existed in different parts of the galaxy, in different solar systems, where the compositions, the elemental abundances, the mineral abundances may have been very, very different. It would be a different picture if we were seeing the first 3 interstellar objects and we'd say, gee, those look exactly like our homegrown comets. That would have been really interesting, and we would have said, well, maybe our galaxy is a boring place because every place is the same. What we're seeing with this is not every place is the same. That's a good thing. Lots of places to explore, and they will be different if we ever manage to get there.
Yeah, I think of these as frozen fossils from their moments of formation, including the things in and now from beyond our solar system. Or in some cases, we point our telescopes at other debris disks, which is just a whole system full of these small bodies. And so now what this will let us do is tell that story in a broader context between the detailed and large library of data we have on those origins of our own solar system and how volatiles were delivered.
How can some random guy with a telescope in his backyard get this image and NASA gives us this?
That got frozen in time from somewhere beyond our solar system, and that small picture of what that was like when that formed.
And the fact that, I love the sort of thought of it as that frozen fossil, almost frozen time capsule. We're kind of privileged. I mean, it's come into our solar system, our sun. We know, we think it hasn't seen a star for a long time. So it's actually warming up and giving us more information. It isn't just about a frozen object coming through and us sort of saying, oh, look, there's a frozen object moving through. But as it's almost waking up and showing us its composition, and that's allowing us to be able to do this great science. If it had just remained frozen all the time, we wouldn't know much about it. But it is the sort of its rendezvous with our star that is allowing us to really do this amazing science. And that to me it makes me feel almost privileged to actually be able to unlock the secrets as this cometary object is coming around and rendezvousing and interacting with our solar system.
All right, let's head over to social media. Nina on X asks, will it hit any planets in our solar system?
No, it will not. I think if you, obviously we're not going to run it again, but please, go online, take a look at go.nasa.gov/3i-atlas and take a look at the trajectory. I kind of talked through it briefly. Tom talked through it, and you can sort of see where those planets are. And remember this, even though it's exciting and it's coming through, space is huge, as both Sean and Tom talked about. And so the probability of it actually hitting anything is super, super small. You have to have all these things aligned to actually be able to do it. But certainly the objects in our solar system will be just fine.
Pretty close, folks.
And we have another question from social media from Astronomeum. They ask, what makes Comet 3i Atlas so different and intriguing compared to the other interstellar comets?
Tom, you want to take that?
The other interstellar objects. We say interstellar objects because not all of them were comets. So the first one was discovered in 2017. That was 1I Oumuamua that behaved very much like an asteroid. Again, a little bit like 3I Atlas, a very interesting asteroid, in some ways different from the asteroids we're accustomed to seeing in our solar system. For one thing, it was seemed to be very, very elongated, and while it was inactive, it seemed to be an inert, mostly rocky object. It did show indirect indications that it was evaporating gases in some way. It wasn't around long enough for us to get really, really comprehensive, long-duration observations and understand exactly what it was doing. It was the very first one. We saw it for a short time when it was on its way out, in fact, and so we didn't get a great view of that. The second object, 2I Borisov, discovered in 2019, behaved, it was a comet.
I hope he knows these dates, folks. I really hope he knows.
In a lot of ways like our homegrown solar system comets, in many ways like 3I Atlas. Its properties were more in line with what we're used to seeing, and the comet observers regarded it as very much akin to our solar system comets, although in some ways a little bit at the edge of what we're used to seeing. 3I Atlas is in a lot of ways like 2I Borisov, but a bit more out there in terms of things like the carbon dioxide to water ratio.
All right, Svetlana on LinkedIn asks, will the observational data from this campaign be available for open analysis?
Absolutely. Every piece of NASA data, we are delighted to share.
After
we've had open data policy at NASA for a long time. We make a big effort not just to release the data, but also to make sure it's usable, so you can get the tools and things to actually analyze the data as well. And we invite everybody to look at this comet with us. If you're able to take your own images through like citizen science programs, we love that too. We love everybody to be sharing in the joy of NASA science as we take every opportunity to take advantage of these incredible visitors to our solar system.
And that citizen science campaign, that includes work that citizens help us do to identify small bodies in our solar system. And so if you really want to get engaged beyond just looking at the data, you can help us generate new data and find other objects for us to study.
Yep, the big one, our solar, our SOHO, big comet finder, big comet tracker. So many of those comets discovered by our citizen scientists. So keep those observations coming.
All right, we'll head back over to the phone bridge. Our next question comes from Ken Chang with the New York Times.
Hi, thank you. This is for Tom and Nikki. One, of the measurements made so far, what is uniquely different about this comet, other than the trajectory, of course? And two, since perihelion, it looks like there are multiple jets. I was wondering if you could talk about that and the speculation that it might have exploded. Thank you.
Go ahead.
Yeah, thanks, Ken. So some of the differences I already mentioned is the ratio, the carbon dioxide to water ratio, the nickel to iron ratio. Also, there were ground-based observations noting that the polarization of the light reflected off the dust was also unusual, so that's telling us some interesting things about the dust. There are other indications that the physical properties of this dust, maybe the grain size distribution, might be different from the sorts of things that we're used to. The appearance of a sunward tail early on in the trajectory was part of that, an indication that the dust was being pushed off the comet on the sunward side, and then it took a while for the solar radiation pressure to push it back the other way. That's been seen before in other comets, but not very often. I'm sorry, Ken, what was the second part of the question?
Explosion.
Did it?
Perihelion.
Jets. Yeah. The jets. Right. So seeing more activity in the inner coma around the nucleus right around the time of perihelion, when it's being warmed most intensely, is something that happens frequently. That's something the comet observers are going to be very, very excited about. It does take some time to figure out, because it takes time for the actual event that happens on the surface to propagate out to a distance where you can see it with a telescope, but people are going to be mapping what jets there are. It doesn't necessarily mean there was an explosion. Jets can also just mean there are particularly active areas on the surface of the comet where more volatile stuff is evaporating in that one spot than elsewhere and jetting out. We saw this a decade ago with the ESA Rosetta mission at Comet 67P. It got up close and personal with the nucleus and saw frequently that there were jets coming out from specific places on the nucleus of the comet. So that could very well be what's going on here. Can't tell for sure, but that's the sort of thing we've seen before.
The other thing I just want to say that we're expecting to see as more stuff gets thrown off this comet in these jets is at those warmer temperatures, additional things can bake off of it, additional gases can bake off, and so we do expect the composition of the coma to potentially change, or those jets to change over time. And looking at the details of what other molecules we detect beyond the carbon dioxide and water we mentioned is also going to be interesting, especially for that sort of like, what was this stuff? What was the area in this? What was this stuff made of in the area it was made, like long time ago?
Right. Our next question is from David Chandler with Sky and Telescope.
Yes, a couple of things. Have you any of these observations showing you anything about any non-gravitational accelerations at this point? And also, can you say a little bit about coming attractions? What observations are in the pipeline that have been made but not released yet? I think the MRO high-rise observations
I've been waiting for this question.
Is there that's
I got this
in the can and waiting to come out, or observations that will be made over the coming weeks?
He's been very quiet.
Object comes
Our guy on the far
Earth.
side, he hasn't said anything.
I can answer some of that about the non-gravitational accelerations. This is something that we look very closely at for every comet, because that's always something that happens. And just to back up to explain what the question is that as comets evaporate, they are blowing off gas, they are blowing off dust, and every time something gets pushed off the comet, that acts like a little rocket engine at that moment and pushes in the other direction. And so it's very, very common to see comets have subtle changes in their orbits as a result of these little rocket forces, just called non-gravitational accelerations. So this is being monitored very closely. I spoke to our orbit determination team at the Jet Propulsion Laboratory earlier this week, and what they said is that this is being monitored. There are some changes to the orbit, but the uncertainties are still fairly large. It's difficult because we can't see the nucleus directly. It's difficult to get a very, very precise track on exactly where it's going. But so far, the non-gravitational accelerations have been very much on par with the sort that we see in solar system comets.
In terms of future observations, this is a situation where, because this is only the third time we've had an opportunity to look at an object like this, everyone that is in control of a telescope wants to look at it because it's a fascinating and rare opportunity. I know that our colleagues from the Keck Observatory have looked at it. I believe that we're going to look at it again with JWST in December. We have some other ground-based facilities that are giving us additional compositional information as those additional molecules bake off of 3I Atlas. Those are the things I'm aware of. There's probably a lot more that I'm not, because like I said, like every astronomer wants to get data on this thing because it's such a rare opportunity.
Yeah, and the high-rise image that you asked about specifically, Amit kind of rolled that out at the beginning. So please take a look at that image. I think Sean is not bragging a lot on what these astrophysics telescope. I don't know why, but because we are able to look at it in infrared with the James Webb Space Telescope, that will be the last time we can see the comet. So as it is exiting the solar system and getting further and further away, the James Webb Space Telescope will actually be able to track it longer than anyone else, partly because of its ability to kind of look long and deep rather than sort of across and wide, and the fact that it looks in the ultraviolet, so in the infrared, so it can kind of see the dark objects. And so I'm really excited about just sort of tracking it to the very end. Also noted we're downlinking data from missions. I mentioned Parker Solar Probe because I just heard before we came on that we'd got some data and we'd seen the comet. I haven't had time to look at the data yet, but all of those things are coming up as we are getting more and more data coming down to us from those missions. And then as both Sean and Tom talked about, just really making sure we're sharpening up those images and really making sure they're calibrated. Right now we're putting out almost the raw images. We're putting out things quickly so everyone can see them, but we'll take some time and do some real sort of deep looking into those and do some more of the spectroscopy. Tom showed a really great example of kind of looking through the atmosphere of Mars, take out that hydrogen, take out the hydrogen.
Don't worry, guys.
From
We'll do a complete breakdown afterwards. I'll just share my thoughts.
From the comet. So
but I
we'll
don't
be
want to
doing a
speak
lot more
over
of
them too
that
much.
as we move on to do great things with NASA science.
All right, that's a great lead into our next question on social media. Elijah on X asks, what kind of processing were the images subjected to and why did they need it?
You want to take that?
The images that were released received the sort of standard processing that we do between the raw data that comes down into a telescope. That, as Nikki said, we need to make sure for scientific accuracy that they're calibrated against the other observations, and we account for anything that the telescope is doing in that moment. And so that it would be our standard set of calibrations and normalizations for a object of this type, which is to say a comet.
I can add a little bit more to that. As Nikki said, our desire was to get these images out to the public as quickly as possible, and so there are some image artifacts in there that you'll see, and I can speak to the Lucy image that you saw previously. If you look at the comet, you'll see some blobs around the comet. The little blobs, faint blobs around the comet are not real. It came from the fact that in order to get this particular view, it was necessary, which is this backlit view, the team had to turn the spacecraft to face more toward the sun than it generally does. And so that means some part of the spacecraft were in the sun, and some of that bright, the sunlight reflected off parts of the spacecraft got into the camera, and that resulted in those little blobs. So that's an example of processing that has yet to be done to figure out exactly what that scattered light contribution was and remove that from the image so that what we show in the image is entirely what was there in the sky and not something just made by sun glints off the spacecraft hardware.
Yeah, and sometimes I think you showed the SOHO image where we actually stacked a couple of images, because a single image you wouldn't be able to see it would be too faint, but if we stack a couple of images together, then you can actually start to really make out what that comet looks like.
Okay, next, Gail on Facebook asks, how can an object like 3I Atlas come from so far, moving as fast as it is, and not hit anything?
Orbital dynamics and space is really, really huge. And so, it is amazing to think about just how big even our solar system. And so to give you the Voyager spacecraft, Voyager 1, is now 1 light day away from Earth, which means when we send a command or we send a photon from Earth, it takes a full day for that photon to arrive at Voyager. And Voyager is only just outside kind of what we think of as the edge of our solar system. And so space is vast. Yes, this thing is moving quickly, and yes, it came from outside our solar system. But the probability of it actually hitting something is so small, because everything has to align. It's also not quite in the ecliptic plane. It's not quite in like our normal. If you think about sort of looking side on at our solar system with the sun, and then you put the planets kind of in a row. Normally, everything sort of orbits in this plane. This is slightly tipped. Not unusual, because it's not gravitationally bound to our sun, but it's slightly tipped. That makes the probability of it hitting it almost even greater.
If I can play with a scale model solar, if you make a scale model solar system where the sun and the Earth are 1 foot apart, that's about 1 foot. The sun is a P, The Earth, you need a magnifying glass to see, it's so small. The entire solar system will just barely fit in your house if you squeeze a little bit, and the next nearest star is over 50 miles away. So they call it space for a reason. Most of it is space.
Okay, we'll head back to our phone bridge. Our next question is from Brandon Spector with Live Science.
Hi, I wanted to ask about the age of the comet. You mentioned there's circumstantial evidence that it's much older than our solar system, but how can we constrain that age a little more? And what will that tell us if it is indeed much, much older than the solar system?
They should have sent the
I can
Juno
start that,
probe
but I'm
to
gonna
it.
pass it to
I mean,
Sean
they
to
could have
talk
planned
about
that
ages in
mission,
the
but they
galaxy.
didn't.
Okay.
So,
we could maybe find out.
So cutting to the end, the bottom line is going to be, it's probably going to be really hard to get a more precise figure from one object. I think what we're looking at in the future, as we discover more of these, when we get to the point where we have maybe a few dozen of them and look at the distribution and properties, we may be able to get a better handle on what the distribution of ages is. So what's going on here is that it takes the sun 240 million years to orbit around the center of the galaxy, and we're doing that with a neighborhood of stars. So we're all going around the center of the galaxy. The relative motions between stars in our solar neighborhood is sort of 10-ish, 15, and sorry, I have all these numbers in my head in metric because that's the way I learned them, but 10 or 15-ish kilometers per second. So what is that? That's about 25,000 miles an hour, I think. And 3I Atlas is coming through at a speed of 60-something kilometers per second. So that's 3 times faster than the average of our local neighborhood, which is telling us that it's coming from a different population from what we have generally around us. Now, Sean will be able to clarify the age dispersion relation in our galaxy, which tells us, which has been discovered over the last century studying stars in the galaxy, that the relative speeds of stars is an indicator of age. Stars that formed older in our galaxy over time increase their random motions for reasons that Sean will explain. And so that's the circumstantial evidence that makes us think that 3I Atlas came from a solar system that had larger motions relative to our solar neighborhood and is older. But it is a circumstantial and probabilistic argument.
So I'm just going to take this opportunity to brag about our telescopes and the James Webb Space Telescope in particular.
Go for it.
This blows my mind. We have data from galaxies closer to the origin of the universe than we have data from rocks closer to the origin of Earth, right? In other words, like if you pick up the oldest rock that we have from Earth, it is further away from the origin of Earth in terms of hundreds of millions of years than the amount of time there was between the origin of the universe and the earliest galaxies that JWST has now observed. And that's part of this story of how well we understand not just the history of our home planet, but the history of the entire universe that it's a part of. And now this is just another part of that story of the local neighborhood that our solar system is a part of.
All right, our last question for today comes from X and asks if we can see grains of sand on Mars. How is the clearest photo we can see for 3I Atlas, what we've seen?
So because we're closer to the grains of sands on Mars, right? And so the JWST can only get like these single pixel blobs of the faintest galaxies, the furthest away galaxies in our universe. And because 3I Atlas is in our solar system, we can get the images and the compositional information with JWST. As it got closer to some of the planetary spacecraft Tom was talking about, they can't even see these galaxies, but because 3I Atlas was closer to them than they were to JW, they got really good images of the object as it passed by.
Right, as you said, we can image individual grains on Mars because we have spacecraft standing on Mars.
Right.
But even our closest spacecraft to 3I Atlas, we're still 19 million miles away.
And it's going too fast for us to send something there to intercept and get that close to it. So that's just not that we just don't have the. If we could. We would, we would be there up close and getting those grains.
All right, well, that's all the time we have for today. Thank you so much for joining us. Be sure to follow along with NASA as we continue to observe 3I Atlas. Find new images, detailed information, and resources by visiting go.nasa.gov/3I-Atlas. and by following NASA Solar System on social media. Thanks for joining.
All right, folks. That was very fun, at least for me in the driver's seat. Hearing the questions, reading the chat. Oh, I had a good time. That was great. Okay, and we have our comparison images. Now, not everyone is in agreement with this here. That's fine. You're never going to get agreement with everybody in life. But I think this is a pretty good, I think this is personally, I think this is just a really good image from an amateur astronomer who applied some photo correction but didn't make up any enhancements. I think they just clarified the image for us. And this is the best image that we have from NASA. So, I mean, that's also the closest image, right? Because this is from Mars, so this is really close up. But in general, I guess I just, I don't want to, I honestly don't want to speak too much. I would say that I don't think any of those people are bad people. I also don't think they were the main scientists or anything involved. They seem to be more kind of behind the scenes management people because there were certain things that they didn't really know. Or they were I think it's going 60 something kilometers per second. I think it's that. So they weren't I think Borisov is in 2019. They weren't right on top of it with the facts. So I think they were more of the media management people, not the main scientists who know this stuff. And I don't think that they're bad people. Okay, so it's, the live stream is hilarious in terms of everything. But press people, not scientists. But I don't want to. We don't need to be rude or disrespectful here. It's okay to have a little bit of fun, but they're doing the best they can. Like the people in the live stream, just those 5 people, I think, and the camera people, everything. They know that people are interested in this, and props for them to take all their different spacecraft and point it at 3i Atlas over the course of time. But why it took them so long to release this imagery is honestly pretty crazy, because I mean, they should have released that on October 3rd. This is October 2nd. Probably didn't take that long to process. I mean, we see this guy process it. He takes in the morning and then releases it within a few hours, right? This should have been released on October 3rd. So you just gotta be real. And some people just aren't real nowadays, right? And yeah, government shut down, but they're taking the time to respond to Kim Kardashian on Twitter. So it's are you actually shut down? I was at the airport talking to TSA, and they hadn't taken any pay for 5 weeks at that point. They're still out there working and hustling. Real good, honest people, you hope. So, yeah, just let me get this next image up. The best image, supposedly, without the additional filler. Here, let's put this one up on the screen. This is supposedly the best image that they have of 3i Atlas from the Mars Reconnaissance Orbiter. And I mean, I really don't even know what to say. I don't even really know what to say. There is some stuff to say here. You'll notice that we do have a pretty high pixel density here. If we're done with the joke show, we notice that there is a pretty high pixel density here. So what we can do, and we can actually do this right now. Let's figure out, well, I'm not sure we're going to be able to. We should be able to. We're doing it live, baby. We're doing it live. Let us open up Photoshop. Here we go. Let me switch over. Okay, so we are going to figure out the brightest pixel and the size of that pixel right now. Because, you know, my commentary at the end of the day, what does it matter? And I'm going to kind of have to guesstimate on this brightest pixel. There's probably some Python script or something that exists that could find it. But let us first calculate. We see 932 miles here. Let's see how many pixels this is. Okay, so I'll go from the inside to the inside. That's 75 pixels across. Okay, 75 pixels for 932 miles. And punch in on this. Oh, that one's pretty bright right there. Let's punch out one more time. I mean, this one is looking the brightest to me. What do you guys say? This pixel? I mean, they're all about the same brightness at this point. There's kind of a zone. There's like a zone like right here that looks pretty much the same. Use a color picker. Yeah, I mean, it's gonna... Okay. Let's punch back in on that one that I thought was brighter. I mean, it pops right out. Yeah, that's definitely not as bright. That one's moving up. If you're watching the color picker, watch that little circle go up. That'll show if it's brighter. That one looks to be the brightest. I mean, it shows up really clearly. I mean, I don't know about you guys, but that like pops right out to me. What do you guys think? Top left of that zone? Yeah, so maybe... It's almost easier to see on my OBS screen here. Maybe like this area right here. Someone's saying invert. Okay, let's try it out. We can do an invert function. Yeah, that kind of helps. Or we can even do a levels function. Let's see what we can... Oh, yeah, you know, that one was definitely one of the brighter ones. Okay, here we go. Now we're using our brain cells, guys. Okay. Oh, yeah. Boom. There we go. Great. Science! She blinded me with science. Okay. Boom shakalaka. Okay, so that looks to be the brightest pixel right here. That bad boy. Let's go to some of these. They're all going to be near the top, but that's, I would say that's probably the brightest pixel. Would you guys agree? Do a thumbs up if you guys agree. Brightest pixel? Yeah. But it's actually, I mean, okay, so at this point, I want to clarify, you can't make interpretations about the structure after I've added this crazy levels filter, okay? So it's not like we're seeing, there's just no way to make any interpretations here other than trying to constrain the brightest pixel. Great, thumbs up, I see you. Yeah, okay, cool. So, you know, let's not like all of a sudden start to, oh, there's some structure to this. We're just looking at pixels here and we're super zoomed in. Let's remember that this is what we're zoomed in on, okay? But we're just trying to find the size of the brightest pixel, which takes us here. And 932 miles is 75 pixels. So let's use our calculator. And we have 932 divided by 75 means that one pixel is 12.42 miles. One pixel is 12.42 miles. And I was looking at the Anakin, I don't like sand meme. miles to kilometer, and we're going to type in 12.42 to get, oh, basically 20 kilometers. Almost exactly. I'll write down it's 19.98805, but 1 pixel equals 20 kilometers, folks. Okay, so she blinded me with science. So as it relates to, hold my beer. As it relates to this, yeah, if we played the drinking game of take a shot for every time they say comet, like you would die. Thank God, even if you did one sip for every time they said the word comet, it would have been bad news bears. Let's turn this off. Well, actually here, let's mark this pixel so we have it here. We use our pencil tool in red and add a layer. You guys can see some of my Photoshop skills because I'm in Photoshop every day on my thumbnails and creating graphics for you all. Hey, are we going to go? Oh, okay. There we go. Great. Now for reference, that's our brightest pixel right there. It is interesting to see that, now again, we can't interpret this too much, but our brightest pixel is offset from kind of the center of the coma a bit, which is interesting. But that brightest pixel right there is 20 kilometers across. Or for the winners in America, that's 12.42 miles. 12.42 miles or 20 kilometers. So I guess what we can say, kind of preliminary, is that if there were a whole bunch of pixels that were roughly that brightness, like again, we can kind of put on our levels here. If there was like a very clear mass that was all roughly the same, then we could probably build out the size of the nucleus a bit more, but it does seem to be pretty isolated there. It's hard to say. I mean, we're really kind of just grasping at straws with this. I mean, you see a little bit of a pocket right there. Let me highlight that. I can almost see it. Yeah, well, this screen I'm looking at is a better screen. So it's kind of like right here. Let's see what happens when I turn on the levels. Interesting how it does that. What about those bright pixels in a line under it? Yeah, well, it's hard to say. You know, they definitely show up brighter. But, I mean, this isn't science at this point. We're just looking at pixels. We're doing this to constrain, hopefully, the size of the nucleus. And it doesn't, based off of this is very preliminary. We can't really work off of this too much. But the nucleus wouldn't be bigger than 20 kilometers across based off of this. That's at least what, you know, Mr. Avi Loeb was talking about a lot, saying we could take the brightest pixel from the high-rise imagery to get a constraint on the nucleus size. And so that's what we're doing in this. And let's look at a few other images. We have our gallery here. Here's our image gallery for 3i Atlas. Oh, I guess I need to go further up. Oh, let's refresh this. Now, people that have been watching know that we've already looked at this. We looked at this already effectively. There were amateurs that processed this data. This is kind of an interesting one here, punch. That shows a nice little orb. we have a GIF. I guess you're supposed to call them GIFs. This movie shows Punch's observations of Comet 3I Atlas from September 28th to October 10th, when the interstellar object was between 231 million to 235 million miles from Earth. Each frame is a daily stacked image made up of multiple observations taken of the comet each day. Stars create streaks of light in the background as the comet moves across the sky. The bright object that appears near the comet in a couple of frames is the planet Mars. Oh, that's interesting. Oh, so here we have the comet. Look how 3I Atlas and Mars are like the same brightness. It's kind of weird. I'm not ignoring the super chats. I am just working on doing, talking to you guys with the stream. And if I had StreamYard, I could go back and look at them. Here we go. One from Atomic Flip. Thank you, bro. Brilliant job comparing the amateur astronomers' photos versus NASA's. What an absolute embarrassment. Yeah. So, but this is interesting that we get this Mars right there. So let's actually download this. Should be able to just go right here. Download this GIF. And I'll have to open up Premiere Pro to get the image graphic. Yeah, GIFs are hard to pause. Oh, I guess I could do a GIF extractor. I'm already doing this. Let's just finish it off. OCD brain is just like, you can do it that way, you can do it that way. It's like, I've learned just don't feed the OCD brain. The ADD brain, whatever you want to call it. You just don't feed it. Okay, so not here, not that folder. You guys get to see my back end. Okay. That's the best graphic right there. So hang on a moment, I'll pull it up in 2 seconds. 3IA with Mars. Okay. 3IA with Mars. Here we go. So here's from that GIF. This is from Punch, which is the polometer to unify the corona and heliosphere. You know, they love their acronyms. Mission to observe interstellar comet 3I Atlas during its passage through the inner solar system. This was from around October 3rd. Put this behind me. So this is 3I Atlas, this is Mars, which is interesting. That Mars doesn't show up like dramatically different. Like I would think Mars would show up as a lot brighter and bigger, but here and like more circular and round, but for some reason Mars is really not showing up well there. So that's kind of odd. Now the ultraviolet instrument is from Maven. We'll check that out too. Don't worry. We're going to get to it right now. But this is kind of bizarre. Now if we go here, so here's what they say. Maven sees 3I Atlas in ultraviolet. An ultraviolet image composite of the hydrogen atoms surrounding Comet 3I Atlas, the third interstellar object ever detected by astronomers as it passes through our inner solar system. The image was taken on September 28th, 2025, just days before the comet's closest approach to Mars by an instrument on Mars Maven spacecraft, which has been studying Mars from orbit since 2014. The instrument, the imaging ultraviolet spectrograph, takes pictures in the ultraviolet part of the spectrum to reveal the chemical composition of objects. The image shows hydrogen emitted from different sources. The comet, which is the dim spot on the left. Hydrogen from Mars, bright emission on the right. And hydrogen flowing through our solar system between the planets, dim emission in the middle. MAVEN's spectrograph distinguished the comet's hydrogen from the interplanetary and Martian hydrogen using a special mode to separate each source by its speed. Hydrogen emission from the comet is confined to the location of the comet on the sky, which is why it's small and round instead of extended. So basically, they just grouped these together, but it's based off of speed. So we see that 3I Atlas is moving close to 60 plus kilometers per second, right? Perihelion 68 when they first detected it, 58 kilometers per second. And the interplanetary field, the solar wind, or I guess this is just interplanetary hydrogen, isn't moving that fast. I would think it'd be moving faster, but it depends, I guess, on what they're looking at. And here's Mars. But Mars, yeah, I guess relative for MAVEN, Mars is moving not that fast at all. It's moving 0 because MAVEN's orbiting around Mars. So I guess that's why they have it. Yeah, speed relative to Mars. Okay. It's interesting, but it doesn't really tell us much. None of these really tell us anything. That's the thing. As far as I can tell, just right off the get-go, it doesn't really do much. I think what we were doing earlier with Photoshop was useful. 20 kilometers for that bad boy right there. 1 pixel is 20 kilometers here. So that brightest patch right here is 20 kilometers across. Seems like that's probably the upper limit. Now, NASA said during their press conference that the upper limit for 3I Atlas's size is 3.5 miles in diameter. That's what they said. They said it was 1,400 feet to 3.5 miles in diameter based off of their best observations. Our brightest pixel there is 20 kilometers across based off of the scale bar of what they provided. But the other big thing that we see here is that this has this sunward facing tail back on October 2nd. Of course, this isn't anything new. That's the problem with this. I'd say one of the biggest things that they announced is that they're going to be turning James Webb telescope to face 3I Atlas for quite a way as it travels out of the solar system. So let's go to our Sky Live here. Let's remove the other 2 interstellar objects, Oumuamua, Borisov. We don't need them. If we look at this, this is 3I Atlas on December 6th, okay? So let's put this back to today, the 19th. Definitely, in general, I mean, okay, so I looked at the NASA live stream chat for just a little bit. As you guys saw in the live stream, I'm seeing people's responses on Twitter because I posted the images on Twitter. X, whatever you want to call it, and then also this live stream. And it's almost like 90% of everybody's pretty disappointed right now. So they did not win. They did not have a home run knockout with that press conference. They've lost a lot of trust clearly. Whether you think it's a comet, aliens, whatever, if we're just stepping back and just analyzing NASA as like an organization, maybe they focus on this, they focus on that, they've done all these things, but as it relates to public perception, they're in the gutter right now. Absolutely in the gutter. But okay, so James Webb is orbiting around Earth, right? That's one of our best deep space telescopes, like basically our best deep space telescope. And if we go back here really quick, James Webb gave us that image of 3I Atlas back August 6th. So super pixely and blurry, didn't really tell us anything. Now though, And maybe it'll just continue to give us that sort of imagery. Now the 3i atlas is going to be moving away like this. And right here is cutting across our frame pretty quickly, but during this stretch right here, we'll see the date here, it'll be like March, February, March, April. This is going to be a really good time for James Webb to observe 3i atlas because our viewing angle relative is not changing much. It's going to be fairly static. Let's go back a couple months, right? We start to have to move our telescope less and less, like especially right here, the relative change is minor, so we'll be able to stack the images better. And then it's also still close in. Now what they're going to do, almost certainly, is that they're going to observe it as best they can, tracking it all the way out. So eventually it'll reach Saturn. Looks like that'll be the end of 2026, maybe middle to end of 2026. Right here reaches the orbit of Saturn. Eventually it's going to go out to Uranus, Neptune, and we'll keep tracking it, I imagine, with James Webb as it continues to go out like this. So if I even pause this, we see that's out beyond Uranus, October 2027. It finally reaches Neptune's orbit in 2028. And then it's out beyond Pluto's orbit here, as you can see, in 2029. So they're going to want to track how 3i atlas changes as it moves now further away from the sun. And this is now a long-term mission because it's going to take some time. Even though it's moving the fastest, it's along that ecliptic plane. It's going to continue to get hit. It's going to, I'm not sure how well we're going to be able to observe it once it's at the heliosphere boundary, which is like 100 AU out. But if I go forward out like this, that takes us to 2041. It's still in our solar system. So they're going to be tracking this as best they can, going all the way out so we can get a better sense of what this thing is. But also by then, we're probably going to have other interstellar objects that have flown in. And, the alien people are going to drum it right back up to, we got aliens, they're back. The aliens are back. They're not done with us. We'll have to see. Who knows? Maybe. But the press conference is kind of disappointing. If I just have to share my thoughts, I feel like they could have done a better job at giving us some information that we didn't know. Like everything that they said was really stuff that we already knew. They ideally, or even they can speculate a little bit. It's not a problem to speculate. If you say, hey guys, like, okay, we don't have the answer, but if we had to, kind of give a lean in a direction, we would say that it's probably this large, or maybe it's from this system, right? Like if anyone is going to have the, they release all this imagery and data saying, hey, we're the best because we have all this, right? But then they're not going to provide any new updates or even possibilities of like how old it is or where it's from. That's kind of the questions that people want to know, right? If you watch the Q&A, all the people are asking like, where is this from? How old is it? What is the size? Is it technology? And they just kind of skirted around those. So yeah, it was fun though. I had a great time. I hope you guys had a fun time with it. I had a good time, but it doesn't look like anything revolutionary has happened with 3i atlas as a result of the NASA live stream. But it will be interesting, mark my words now, it will be interesting to see how people start to spin this, because there are a few spinsters out there. Maybe you think I'm one of them. That's fine. You're entitled to think whatever you want. But there are definitely some spinsters out there that'll take the tiniest image, shred of information, whatever, and turn it into a huge thing. In general, I'm just doing my best to report on what's happening, not to make fake stories. But it's going to be interesting to see what sort of back of the napkin calculations get spun up as a result of this, and then using that to infer properties of 3i atlas. Effectively, this is what we can say. None of this information here, as far as I can tell, or we'll have to wait and see. But as far as I can tell, based off my research, everything I've been doing into this, informing you guys, it does not change at all what we know about this. So there's no fresh update on this in terms of size, where it's from, what it may be. There's really no update. It's just, here's all our images that we should have been releasing to you when we had them, but instead we didn't do it until now. So that's kind of the bigger disappointment, is that we had this shut down in the United States, and they were shut down, but they weren't shut down. All this ambiguity. Who knows what the truth is? It's all over the place. So, yeah, fun was had by all except for Dr. Shazam on the left. Yeah, that guy didn't say anything after the beginning. He was dead quiet. He's like, I know that this is spiraling, and I'm just going to sit here and eventually I'll be done. Yeah. Yeah, so exactly. They sat on the imagery and there was no reason to sit on it. That's the thing. So, a little disappointing. We can see what Twitter is saying really quick, and then I'm going to sign off. Is this what 20 billion a year gets us? Yes, it is. Oh man, this is funny. I've had I've had a great time with this live stream. It's been a blast, at least for me. I hope you guys have had fun. This is my Twitter post on it. Best image of 3i Atlas from the live stream. Or how about this one? This is our ultraviolet image. I wonder if they show the size of that to give us a size estimate for MAVEN here. Let's go back. Okay, here we go. 100,000 miles at Comet. So let us download this. We're not done yet, folks. We're getting close to wrapping up, but we're going to see this all the way through. Let's see how big this brightest pixel is. Okay. Okay, class. So today we're going to, let's look at this. I have to really, there we go. Okay, so we have 380 pixels across for their scale bar. Okay. 380 pixels for their scale bar. And that's 100,000 miles. At the whatever. Here's MAVEN with this ultraviolet. This is why it's interesting. It's ultraviolet. With a very clear, bright pixel in ultraviolet. And I would say that's 127. 127 pixels. Go back to our calculator. You do 100,000 divided by 380. So it is 263 miles per pixel. And then we do that times 127, because that's how many pixels across that is, and that's 33,421 miles. So if we zoom out, is that right? I guess that is right. Yeah, that's about right. Should be right. Let's try that one more time. 100, just to make sure. You always want to double check math and stuff. 263 times 127. Yeah, so this brightest pixel in ultraviolet taken from MAVEN is 33,421 miles across. So it really does start to fade off after that. But again, we're grasping at straws here. I measured the white line. Yeah, it's 380 pixels. So this is, I mean, we really can't get much from any of this, honestly. I'm doing the best I can, but there's really not much to do here. I'm not even sure this is worthwhile, but it's been worthwhile to be here in the live stream and chat with all of you guys and to have some fun. You know, laughter is good for the soul, so it's certainly been worthwhile, all of that. But I think that is going to be it. No need to drag out what does not need to be dragged out. I thank all of you for being here in the live stream. I hope you found this entertaining at the very least. And again, I want to say, you know, they didn't have to go through the whole production of a live stream. I personally don't think they should have, but you have to respect the effort. And also, you know, as someone that used to not be good on camera and knowing what that feels like to have a camera on you and know that there's like 100,000 people watching your live stream, you know, you have to give credit where credit's due. So props to the 4 people that went on camera for their NASA live stream that, you know, they knew a good amount, but they didn't know maybe as much as they should. So they also came in a little underprepared, I would say, which makes it even more difficult. So, you know, I would have liked to see someone that really knew their stuff sit down and like do a really good Q&A, like ideally just one person. But I get it. So, you know, yeah, they're in the hot seat and we have the images now. It's going to be really interesting to see how everyone starts to spin them around. So I'll keep you up to date on what is happening as best as possible with what is the truth. I'm not interested in just spinning up fake stories just to spin up fake stories. It doesn't help you in the long run. So that is my promise to you. And we also cover what's happening with the sun, earth, and cosmos. So if you like the sound of that, then please subscribe to the channel. And yeah, that's it. I've been your host, Stefan Burns. Thank you all. Wishing each and every single one of you well. Please take care of yourselves. And I'll see you all in the next video.